Sectors and arc lengths of a circle. Unit 10, Topic 4. Here we have that circle from our formula sheet. And this letter C stands for circumference, the length around the outside of a circle in one-dimensional units, centimeters, meters, inches. You can trace it with your finger. Now, let's look at a term called arc length. So the circumference is all the way around the circle. What we'll find with arc length is, it's the length of an arc on the outside of a circle. It's only going to be a small portion. So on the left, we see a circumference. It goes all the way around a circle. And on the right, we just have an arc length with an angle across from it. We're going to find that if we take that little angle out of 360 and multiply it by the entire circumference, it's going to be the actual arc length. Again, our formula sheet. And now let's talk area. How much it takes to fill in a shape. This is going to have two-dimensional units, centimeters squared, meters squared, inches squared. Think of painting something. You're covering a surface. To go along with area, we have something called a sector. Now, a sector is the area of a piece of a circle. Think of pizza or a pie slice. It'll also be in two-dimensional units, though. It's still something we could paint or cover. So on the left, I see the entire area of the circle. If I filled in the entire thing. On the right, I find that a sector is just a slice that covers a specific angle, x. To solve for my sector, I can take that little x out of the whole thing, 360 degrees, and multiply it by my area. That's going to equal the area of my sector. Let's actually find the arc length of arc AB. Here's AB. I know that a full circle is 360 degrees. An arc length is a fraction of the circumference of a circle. To show that fraction, I'm going to take the angle across from my arc, divide it by 360 degrees, the whole thing, and multiply it by my circumference. This will be my arc length. To find the arc length, first we'll solve for the circumference. Thinking back to topic 2, I know that I'm going to need either a radius or diameter to find my circumference, and because I'm given a radius, I'll solve using the radius. My circumference is 2 times pi times r. Because my radius is 6, my circumference is 2 times pi times 6 feet. Simplifying, I find that my circumference is 12 pi feet. I'm going to leave the pi there for now. I'll simplify later. Now, we're going to multiply the circumference we just solved for by the fraction. The full circumference is 360 degrees. More accurately, the full circle is 360 degrees. The arc only travels 135 degrees. That is, the arc goes 135 out of 360 of the entire circle. So my arc length will equal 135 out of 360 times my circumference. So my arc length is 135 out of 360 times my circumference, 12 pi feet. Simplifying in my calculator, I'm going to plug in 135 divided by 360 times 12, and then convert it to a fraction to find that my arc length is 9 pi over 2 feet, or about 14.1 feet. Check this in your calculator now to make sure that you're successfully finding the correct answer. Now let's find the area of the sector that is shaded. I know that x out of 360 degrees times my area, that's the total area, will equal the area of my sector. So first, let's solve for the total area. To solve for area, I'm going to need a radius. My area is pi times r squared. Because I see my radius is 3, my area will be pi times 3 squared feet squared. Simplifying, my area is 9 pi feet squared. And remember, I'm going to leave the pi to simplify later. Now that I have the area, I'm going to multiply this area by the fraction. So if I take my x out of 360, that is the degrees I actually travel in my shaded sector divided by 360, times my total area, it'll equal the measure of my sector. Because my x is 70 degrees, I'll say that 70 out of 360 times the area, 9 pi feet squared, equals my sector. Multiplying and then simplifying the fraction, I find that 7 pi over 4 feet squared, which is approximately 5.5 feet squared, will be the area of my sector. Not too bad, right? Now let's find the circumference of circle D. That means that I'm given an arc length, and I'm going to need to solve backwards to find the total circumference. Well, I know that my x out of 360 times the total circumference will equal the arc length. Because my x is 40 degrees, that means that 40 out of 360 times the circumference that I want will equal my arc length, which is 4.19 inches. To solve for my circumference, which is right now multiplied by 40 over 360, I'll divide both sides by 40 over 360. Notice that I put my fraction in parentheses. That way there are going to be no errors. So evaluating, 4.19 inches divided by 40 over 360 means that my circumference will be 37.7 inches. Notice that it's larger than my arc length. The total circumference is always going to be longer than just a piece of the circle. It makes sense. Now let's find the area of the following shaded sector. Oh, excuse me. The area of the following shaded sector is 49.1 centimeters squared. Let's find the area of the entire circle. So our shaded sector is the sector at the bottom. So the x, the angle that I need, will be inside of the shaded sector. All that I have is the unshaded part, but I know that a full circle is 360 degrees. Therefore, that x plus the 135 degrees that I'm given will have to equal 360 degrees. So solving for x, I'll subtract 135 degrees from both sides, and I find that x is 225 degrees. Now taking my area and sector formula, I know that 225 degrees out of 360 times my area will have to be 49.1 centimeters squared. Solving for area, I'll divide both sides by my fraction, 225 divided by 360. Plugging this into my calculator, 49.1 divided by the fraction 225 over 360 means that my area will be 78.6 centimeters squared. Right? The area of my shaded sector was 49.1, so it makes sense that the area of the entire circle would be larger.